Hello everyone, my name is Wendy, and along with my colleagues Shanae and Myron, we have created this presentation on cognitive science and intelligence. This is our table of contents. I will start off with the introduction, followed by Janae going over the methods section, and then we will end with Myron and the results. The article that we chose is called Associations Between Different Dimensions of Prenatal Distress, Neonatal Hippocampal Connectivity, and Infant Memory. This study aims to investigate the impact of different dimensions of prenatal maternal distress on hippocampal functional connectivity in neonates and learning and memory in young infants. In this article, it is essential to first understand what prenatal maternal distress is. It is a concept that encompasses numerous psychological states such as anxiety, stress, and depression. Certain psychological states have been connected with changes in the anatomical and functional development of the infant brain when studied individually. In a similar fashion, these variables of distress are also risk factors for psychiatric disorders such as ADHD, depression, and schizophrenia, as well as cognitive impairment in infants. As it connects with prenatal distress, the hippocampus is a frequent subject of brain research. The hippocampus is crucial for inhibition, memory, and spatial cognition. It is also affected in a number of psychiatric disorders and has a high concentration of glucocorticoid receptors which can regulate the homeostasis associated with stress. These receptors may make the hippocampus more susceptible than most other brain regions to maternal anxiety, which may involve disruption of the hypothalamic pituitary adrenal axis and atypical cortisol exposure in the fetus. The hippocampus is consistently altered by prenatal maternal stress. We also wanted to demonstrate how other research has shown that prenatal maternal stress can impact the hippocampus in rats, primates, and humans. In rats, prenatal stress during the last trimester of pregnancy changes the expression of proteins essential for brain plasticity in the hippocampus and impairs spatial memory. In primates, prenatal stress has been linked to 10-12% reductions in the hippocampus volume. Finally, in humans, increased prenatal maternal anxiety has been linked to similar left hippocampus sizes in school-aged children and slower growth of both hippocampi between birth and 6 months of age. Now we will be going over the methods of this study.
Hi everyone, my name is Janae Galloway, and today I will be going over the methods section of the research study. The participants included pregnant women between the ages of 14 and 19 years old. These participants were collected from Columbia University Irving Medical Center in the OBGYN department. The researchers wanted to study pregnant women within this age group considering this population has a higher risk for stress. It was important to the study to ensure the participants were within their second trimester. The participants had no major health issues prior or at the time of recruitment. The infants were measured for maternal distress throughout the second and third trimester to examine impact on hippocampal function connectivity. They later, at the age of 4 months old, postpartum, had resting state functional magnetic resonance imaging. There were 4 measures of maternal distress that the researchers wanted to use. Each of these 4 measures were used in the second and third trimester for the participants. The first one was the Perceived Stress Scale, which is a self-report measure that includes 14 items for the participants to assess situations that are deemed threatening. This was also administered again postpartum when the infants were 4 months old. The second measure was the Reynolds Adolescent Depression Scale, which is also a self-report measure that includes 30 items to assess depressive symptoms. Next, researchers used the Pregnant Distress Questionnaire to assess the participants' pregnancy-related distress that particularly pertained to fear in regards to pregnancy. Lastly, the Ambulatory salivary cortisol was collected during the study session from each participant. The mobile conjugate reinforcement task was administered to the 4-month-old infants, which was described as a reliable measure of infants' memory and learning. It included tying a ribbon to the infant's ankle, and the other end of the ribbon was attached to a mobile on the infant's crib. The purpose of this was for the infant to learn the connection between kicking their leg and the movement of the mobile. So again, this examines the memory and the learning of the infants. Common Space Registration. A study-specific Common Space template was created using the anatomical images from all study participants. To create this template first, anatomical images were skull stripped and any remaining non-brain tissue was manually removed. Anatomical images were then linear aligned to a single infant anatomical scan from an independent study using a 12-parameter affine registration by maximizing the normalized mutual information between images. After the anatomical scans were registered to the Common Space template, functional images were rigidly aligned to the anatomical images. Connectivity processing. Motion correction was performed using SPM8. Images were warped into 3 mm common space using the nonlinear transformation described above and cubic interpolation. Images were smoothed until the smoothness of any image had a full width half maximum of approximately 8 mm. This iterative smoothing reduces motion-related confounds. Several covariates of no interest were regressed from the data, including linear and quadratic drifts, mean cerebrospinal fluid signal, mean white matter signal, and mean gray matter signal. Seed connectivity. Whole brain seed connectivity was assessed independently from the right to left hippocampus. Seeds were manually defined on the reference brain and included the hippocampal head and body. The time course of the reference region in the given participant was then computed as the average time course across all volexes in the seed region. This time courses were correlated with the time course for every other volex in the gray matter to create a map of R values reflecting seed to whole brain connectivity. These R values were transformed to Z values using Fisher's transformation, yielding one map for each seed and representing the strength of correlation with the seed for each participant. Lastly, experiment design and statistical analyses. Analyses performed using SPSS 23, p-values greater than 0.05 considered statistically significant. Demographic and behavioral data was analyzed using the chi-squared test statistics or the Fisher exact test for categorical data, contiguous data using t-test, Mann-Whitney U-test, and Spearman rank correlation, and lastly, imaging data, volex-wise linear models.
Now we will be going over the results of this study.
Hello everyone, my name is Miran and I will be providing a brief summary of the results. With regards to demographic characteristics, the average age of the pregnant women was 17 years. The majority was Hispanic and over half completed high school. The majority of infants were male and were delivered vaginally. All infants were appropriate size for gestational age and were scanned at an average 42.4 weeks post-menstrual age. Regarding associations of maternal perceived stress with hippocampal connectivity in neonates, higher maternal perceived stress as measured by the PSS was associated with weaker connectivity between the left hippocampus and dorsal anterior cingulate cortex. Associations of maternal depression with hippocampal connectivity. Higher maternal depressive symptoms as measured by the RADS associated with weaker connectivity between the left hippocampus and posterior cingulate cortex, and with weaker connectivity between the right hippocampus and PCC. Associations of maternal pregnancy-specific distress with hippocampal connectivity. Higher maternal pregnancy-specific distress, as measured by the PDQ, associated with stronger connectivity between the left hippocampus and right temporal lobe. Controlling for co-occurring dimensions of maternal distress. All maternal distress hippocampal connectivity associations had similar effect sizes when controlling for co-occurring maternal distress, with the absolute values of the correlation coefficients ranging from 0.48 to 0.67. Controlling for second trimester maternal distress. Associations with perceived stress and pregnancy-specific distress had similar effect sizes, with the absolute values of the correlation coefficients ranging from 0.43 to 0.65. Associations of neonatal hippocampal connectivity and infant memory. Higher maternal perceived stress during the third trimester, associated with lower long-term retention ratio on the mobile conjugate reinforcement task administered at 4 months. Connectivity between the right hippocampus and a DACC associated with infant memory, such that higher connectivity resulted in a higher long-term retention. Maternal distress measures collected during the second trimester. In an exploratory analysis, the authors repeated the analyses using distress measures collected in the third trimester with those collected during the second. The authors did not observe any associations between the PSS, RADS, or PDQ and the left or right hippocampal connectivity. Spatial overlap of effects. The authors computed the overlap of all detected maternal distress hippocampal connectivity associations, with the exception of a small cluster of overlap between the maternal depression and pregnancy-specific distress clusters in the right temporal lobe. All clusters were spatially distinct. Perceived stress correlated inversely, and hippocampal connectivity correlated positively with infant memory. Maternal cortisol collected during the second but not the third trimester correlated with the strength of hippocampal connectivity in the ACC, insula, and temporal lobe. Consistent across multiple dimensions of maternal distress collected during pregnancy, the authors showed that third trimester distress likely influences the developing brain. The findings provide evidence that prenatal distress is associated with hippocampal networks implicated in stress, long-term memory formation, and psychiatric illness.
Thank you, and this concludes our presentation.